All right, so the goal of this video is to explore something called Euler's number, okay, which is, or I'm sorry, Euler's number, which is denoted by the letter E. So we're going to start off by doing a quick review of something you've already seen, which is compound interest. So I have up here the compound interest formula, right, and down here at the bottom, I just have a quick example of that we're just going to go through. So whenever we do compound interest, we typically need to know the starting value, which is P. We need to know the rate, which you can see down here I have 3.5%. We'll turn that to a decimal. We need to know how frequently we are compounding, and in this case monthly will be the n values. And we need to know the number of years. So if we just take all this information and we plug it in, okay, we're going to have something that looks like 1,000, okay, 1 plus 0.035, which is if I move this decimal over twice, right? That's what you get, okay? Over. Monthly means that we're going to have 12 occurrences, right? It's going to happen 12 times, okay? And then my exponent is going to be that end value, which is 12, times the number of years, which is 5, right? And that's going to make this a 60, okay? And then you can type this in your calculator. You'll get a value out, and you're done, okay? So this is the kind of old stuff that we used to do. Hey, but we run into a little problem, and I'm not going to do this whole problem, but just to kind of explain where we're going, okay? You can see that if I were to give you a situation where I change the compounding, right? We have a regular compound interest problem, and we decide to do the compounding more and more and more frequently. So if we did yearly, right, that's going to be an n value of 1, okay? If we do semi-annually, that's an n value of 2. That's twice a year. Quarterly is an n value of 4, right? Monthly is an n value of 12. So you can see my n is getting bigger and bigger and bigger. Daily is 365, okay? And then here's where things get interesting. If I were to do hourly, I'm going to need my calculator real quick because I have to do 365 days times 24 hours per day, right? And that's 8,760. And then I can get crazy, right? And if I wanted to, I could say, well, what happens if I compound every minute? That means each of those hours is going to be times 60 minutes, okay? That's a big end value. And then if I wanted to do seconds and say, you know what, every single second we're going to compound, and I'm going to do times another 60 for 60 seconds, okay, you get this really gigantic n value. And here's where we're going with this, okay? As n gets bigger and bigger and bigger, we'll find that the total payment does not get all that much bigger. We eventually reach like a highest point, okay? And so that highest point that we reach is essentially like this value at the top here, this 2.7 number, okay? If I were to make this like a billion for an n value, it would really not be a whole lot higher than it is right here. In fact, it probably wouldn't be a whole lot higher than it was when we were just doing like hourly, okay? So we eventually get an n value that's big enough that it approaches this number here, about 2.72. This number is what we call Euler's number, okay? And I know it looks like it says Euler. I made that mistake too, but it's referred to as Euler's number, okay? So the number E, which I'm going to pull my calculator again real quick, okay, it does have an E value here. If you see, if I click on that, there's your 2.72, okay? So this is a special number, very similar to pi, right? That is about 2.72, okay? And it is something that we'll use a lot in situations where the growth and decay rate is what's called continuous. Okay, and what this means is that if I were to say, how frequently is this happening? The answer would be, it's always happening. Like, I can't say it's happening, at minute 1, and then at minute 2, and then at minute 3, and then at minute 4. It's literally happening all the time. So a really good example of that is if you talk about plant growth, I think is a good example, right? If I were to say, the plant is 2 inches and then, the next day it's 3 inches, we didn't say it magically went from 2 inches to 10 inches or 12 inches, right? It's kind of very slowly, minutely growing every single moment of the day. It's a continuous change, not something that just happens on the first day of the month or something like that, okay? So these are some examples of continuous growth or decay. So interest, obviously. Okay, if we were to talk about radioactive decay in chemistry, you'd probably talk about half-life. That is a continuous a decay, right? That would use E, right? So these are some examples of what you might see. So what we're going to do is make a slight change to our formula, right? If I were to say that I wanted the compounding to happen continuously, right? Instead of saying compounded monthly or compounded daily or whatever, I say compounded continuously. we don't have an n value anymore because it's so big, it's happening so fast because it's literally happening all the time that we don't have an n value. So we can't use this compounding formula anymore. Instead, we're going to use this one. Okay, and this is the big point of this particular day. So I'm going to grab my highlighter and go over that. Okay, this is the formula that you're going to need whenever a problem says that it's being compounded continuously. Instead of using the regular compound formula, we're going to use the one that contains e, right? And so again, if we kind of break this down, p is the same, right? That's the same p value that we see up here, the starting value. E is this special number, okay, button on your calculator, right? 2.72, okay? R is still the rate as a percentage, and T is still the time in years. So those things have not changed. The only thing we did was we replaced the N's with this E value, right? So if I were to give you a problem like this and just ask you, like, what is, we'll just do the last one here. If I were to, or maybe we'll do the second one. What is 10 times E to the 0.02, or 0.2? I can just go to my calculator, start off with E to the 0.2. So I'm going to clear everything out, okay? And I'm going to do E, and I'm going to raise it to the 0.2. Okay, and get that value, okay, and then I'm going to go multiply that answer by 10, right? So very similar to what we did with the compound interest formula, right, where we figured out what was going on with the parentheses, and then we multiplied by that starting value. You're going to do the same thing, okay? So you have this E button on your calculator that you're going to use, okay, and here's where you're going to use it, okay? If I were to give you a problem like this, and say you owe $12,000 to Business Sloth here, and it is compounded continuously at a rate of 4% for 3 years, we're just going to plug this information in, right? So we're going to say, not with a highlighter. Let's grab my pen, okay? So we're going to say that, excuse my pens being weird. There we go. All right, so that should do. We'll just leave that up. There we go. All right, so because we see this word continuously showing up, we're going to use the formula P, E, we call it PERT, right? Principal times e to the rate times time, okay? So I'm going to plug in this information. It is a $12,000 business loan. Okay? E is E, which will replace when we do the calculator part. That's going to be the 2.72, okay? And then my rate is 0.04, okay? And my years is going to be times 3, okay? So if I go to my calculator now, I can just plug all this information in, okay? And we're going to say, again, starting off with E, okay, you can do this separately or off to the side. 0.04 times 3 is 0.12, right, 0.12. So I'm going to raise E to the 0.12, okay, get my answer. There it is. And then I'm going to multiply that by 12,000, okay? And there we have about $13,529, right? So that's the idea with E, is that it's just this button on your calculator. It's a special number for continuous change, right? We can do something similar with different other problems, but we're going to stop right there. So you're going to get some problems where it just asks you to apply this, and you may be asked to switch between compounding continuously and compounding monthly or daily, where you'll have to switch between these two formulas now that we have, right? So just to go back and show you the important slide, right? We have this one, right? So this first one is for values of n, like monthly, daily, and all that. And then if they talk about continuously, then you'll switch to this one.